Good afternoon. I hope everyone is having a great day. Today I am going to be working through the Unit 1 study guide. The test for Unit 1 is going to be this coming Monday or Tuesday. Monday will be an A day, Tuesday will be a B day, so make sure you are fully prepared for that test. I highly recommend that you have worked through some of these problems already before watching this video. You should be seeing what you know compared to what you need to know before this date. I am going to do my best to make this as detailed as possible so that it benefits you the maximum it can. Number 1 asks us to simplify the square root of 125, and the method that I taught you for simplifying radicals requires you to find two factors of your radicand. Because 125 ends in a 5, I know that 5 is a factor. So I'm going to divide 125 divided by 5, and I get 25. So I can break this down into 5 and 25. 25 can be broken down also into 5 and 5. Once I break a number down, I'm going to cross it out. Once I am at all prime numbers, I am done breaking the number down, and I need to circle any pairs and box any numbers remaining. So I have a pair of 5s with one 5 remaining. Remember that pairs go on the outside, so I'm going to just add that to our study guide. Pairs go outside. Boxes go inside. So this would become 5 square root 5. Remember that I have a coefficient of 1, so my last step would be to multiply my coefficients. 1 times 5 is 5, so this stays 5 square root of 5. Number 2 is also a radical question. This radical question is an addition and subtraction radical question. So the first thing I need to do is look and see if any of my radicands are the same. I have a radicand of 11, a radicand of 44, and a radicand of 12. None of these radicands are the same. Because none of them are the same, I'm going to see if any of them can be broken down or simplified in order for us to get a similar radicand. This first one, the square root of 11. 11 is a prime number, so its only factors are 11 and 1. I know that because it's already prime, it can't be broken down. So I'm going to jump to 4 square root of 44. 44 is not a prime number. 44 can be broken down into 2 and 22. 22 can be broken down into 2 and 11. Because I broke down the 22, I'm going to cross it out. I have a pair of 2s with one 11 remaining. So this becomes 2 square root 11. I know the 2's go on the outside and the 11 goes on the inside because for number 1, we said that whatever number is paired goes outside, whatever number is boxed goes inside. I can't forget about my coefficients. So I'm going to multiply 4 times 2 to get 8 square root of 11. Lastly, I'm going to break down 3 square root of 12. 12 can be broken down into 3 and 4. 4 can be broken down into 2 and 2. I have a pair of 2's with a 3 remaining. So this becomes 2 square root of 3. I'm going to multiply this coefficient of negative 3. So this becomes negative 6 square root of 3. I'm going to drop down my square root of 11 and the plus sign. So this becomes the square root of 11 plus 8 square root of 11 minus 6 square root of 3. Because these two square root of 11s are the same radicand, these two can be combined. So they're like radicands, they can be combined. So 1 square root of 11 plus 8 square root of 11 is 9 square root of 11. And this minus 6 square root of 3 does not have a like radicand, so I'm going to leave it as minus 6 square root of 3. And that would be my final answer. Number 3 is another radical question. This is a multiplying radical question. When we are multiplying radicals, we multiply the outside, multiply the inside, and then simplify. So it's a 3-step process. So what number do I have in front of this? I have an invisible 1 and another invisible 1. I'm going to multiply 1 times 1 because those are my outside numbers. 1 times 1 is 1. I'm going to multiply 6 times 30. You can use my calculator. 6 times 30 is 180, so this becomes 1 square root 180. I'm not done there because I need to simplify this. 80 can be broken down into 90 and 2. 90 can be broken down into 45 and 2. 45 can be broken down into 9 and 5. And 9 can be broken down into 3 and 3. Once I have all prime numbers, I'm going to see if I have any pairs. I have a pair of 2s, a pair of 3s, and a 5 left over. My paired numbers go on the outside, so I'm going to have 2 times 3 on the outside and 5 on the inside. 2 times 3 is 6. The 5 stays the same, so my final answer is 6 square root 5. Number 4 is another simplifying question. First thing I need to do for this one is to break down 81. Everyone should have a little bell going off in their head because the square root of 81 is a perfect square. The square root of 81 is 9. But you could break down 81 into 9 and 9. 9 could be broken down into 3 and 3 and 3 and 3. You cross out both 9s. I have a pair of 3s and another pair of 3s. This question does have variables, so I need to make sure that I write out my variables. X to the third, I draw 3 x's. Y to the first, I have 1 y. I'm going to do the same thing with the variables that I did with the numbers. I have a pair of x's with 1 x and 1 y remaining. At this point, I'm going to put my pairs on the outside and my boxes on the inside. On the outside, I have 3 times 3 times x, and on the inside, I have x and y. 3 times 3 is 9x square root of xy. So that would be my final answer. Alright, so now we're going to move into classifying numbers, and there are only 2 classifying number questions on your test. The first one's going to ask you to classify several numbers as rational or irrational, or it's going to have you identify a list of all rational numbers or irrational numbers. So first things first, -7. -7 is a rational number, and it could also be classified as real and an integer. Remember, our classifying system goes real, which breaks off into rational and irrational. Rational numbers can then be classified as integers, whole numbers, and natural numbers. So -7 is an integer because it's negative. Negative square root of 21. I'm not sure what that would be, so I'm going to type it into my calculator. Negative square root of 21, and I'm going to hit enter. negative square root of 21 is negative 4.5825, blah, 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 blah. Because it's an ugly decimal, I know that it is irrational. Pi. Pi is irrational. That's the easiest one to remember. And the square root of 144. If you're not sure, check the square root of 144 is 12. 12 is a rational number because the square root of 144 is a perfect square. Number 6 is very similar. It's asking you to classify negative square root of 100. Whenever I have a square root, if I want to check if it's rational or irrational, I just type it into my calculator. So I'm going to type negative square root of 100, and I get negative 10. So instead of dealing with a square root, I'm going to deal with negative 10. Negative 10 is a real number because all numbers are real numbers. It is rational, so it is not irrational. When you are deciding if it's natural, whole, or integer, I always start with natural numbers. When I count with negative 10, I start with 1, 2, 3, 4, so I do not count with negative 10. Whole numbers start with 0, 0, 1, 2, 3, 4, 5. It is not a whole number. Integers are positive and negative whole numbers. So because it is negative 10, it is an integer. So the classification for negative 10 would be integer, rational, and real. Go ahead and flip the page. Alright, number 7 can be a little tricky, but you just have to think about the rules of rational and irrational numbers. So number 7 wants us to circle all of the numbers that when added to a rational number will give you an irrational number. So I know that a rational plus rational equals a rational. An irrational plus rational equals an irrational. So right now I'm looking for irrational numbers because I want an irrational sum. This is a quick cheat sheet you might want to write on your paper when you're taking the test so that you could figure out what type of number you're looking for. I'm looking for all of the irrationals. 4.543 ... This ... means that it's going to keep going on and on and on forever. Because it keeps going on and on and on forever, it is an irrational number. 45 is a rational number. 1/4, all fractions are rational, so that is a rational number. Pi is an irrational number. And I'm not sure about the square root of 21, so I'm going to type it in my calculator. I get an ugly decimal, so that is also an irrational number. So any of these irrational numbers added to a rational number will give me an irrational number. Good. Alright, we can finish one more for this video. So number 8 says that a square picture frame has an area of 120 square inches. So I have a square picture frame and it has an area of 120 inches. I know that area equals base times height, and I know that in a square the side lengths are all the same. So I'm going to label these X and X because I know that squares have all the same length sides. Because the area formula is base times height, I could say that the area for this picture frame would be X times X. They tell me that the area is 120 square inches, and X times X is X squared. To solve for X, I'm just going to take the square root of 120. In my calculator, I could type the square root of 120, and I get 10.95. So each side would be 10.95 inches. We'll continue in the next video.